Hello friends, my name is Manoj Chaudhary and welcome to this session on some special problems on tangents and normal. If you remember in my previous video, we already discussed the entire concept of finding various equations of tangents and normal to the given curve at given point. So before watching this video, make sure you already watched my previous video on tangents and normal to the curve. Today we will see few very interesting special cases on finding equations of tangents. These are not the general cases, these are not the given database problems. These kind of problems are somewhat tricky and very important for objective examinations. So let's start with problem number 1. So here you have to find the point on the curve. This is the equation of curve, and you have to find a point on that curve where the tangent is parallel to this line. So if you observe, this is not an ordinary problem like finding the equation of tangent and normal to the curve. This is something different, and that's why these are important for the objective examination. So if you remember in my previous video, we already covered derivative, this very important concept. Derivative of a curve or dy by dx is nothing but the slope of tangent. So I am talking about this very interesting and very important concept. Derivative is nothing but slope of tangent, and the second thing, slope of normal is negative reciprocal of slope of tangent. So these are the few things that you have to remember to solve these questions. Okay, so let's start with this question number 1. So this is the given equation of curve. So I am talking about question 1. So given equation of curve is, or the function is, y equal to x cube minus 2x square minus x, and to find the slope of tangent you must differentiate this given curve. So I am differentiating this given curve with respect to x. So let's find the derivative of this x cube minus 2x square minus x individually, because everything is present in addition and subtraction. So this dy by dx is equal to derivative of x raised to n is n into x raised to n minus 1. It's a 3 into x raised to 3 minus 1, that is 2. Taking this 2 outside, derivative of x raised to 2 using again derivative of x raised to n is n into x raised to n minus 1. 2 into x raised to 2 minus 1, and you know that the derivative of x with respect to x is 1. So finally, what is the derivative? So derivative is 3x square minus 4x minus 1. So here we got the derivative, and you know that derivative is nothing but the slope of tangent. So this is nothing but the slope of tangent. Slope of tangent, right? So we can say, so slope of tangent is nothing but the derivative, and is equal to 3x square minus 4x minus 1. Okay, so here we reached up to this point and we got an expression for the slope of tangent to the curve. So this given curve. Now, according to them, the tangent is parallel to this given line. So understand this. So here I am mentioning the equation of given line. So now let's mark this as 1 somewhere. So what is the equation of given line? So friends, the equation of given line is 3x minus y plus 1 equal to 0. So let's find the slope of this line. So if for a general line is ax plus by plus c equal to 0, then slope of such a line is minus x coefficient divided by y coefficient. So this is the data that I am taking from the coordinate geometry chapter line. So this is ax plus by plus c equal to 0. Then slope of the general line is always minus a divided by b. That is nothing but the minus x coefficient divided by y coefficient. So slope of this line is minus, I am using this formula, minus x coefficient divided by y coefficient is minus 1. So finally the slope of this line is 3. So here we got the slope of this line. Now according to them, this line is parallel to the required tangent. So let me explain you with this simple graph. Let's say this is the curve. Let's say this is the graph of this given curve, and we are trying to find a tangent which is drawn to this particular curve. So what you have to find out here is point on the curve where the tangent is drawn. So here, let's say this is the point A, which is the requirement of the problem. So right, are you understanding? this is the point A, which is the requirement of the problem, where the tangent is drawn, but according to them, this tangent is parallel to this line. So let's see, this dotted line indicates, I am drawing it tentatively, not with the exact scale or with exact notation, but let's say this is the line. So this is just a rough sketch or rough understanding of the problem. So even the drawing this sketch is not at all important in the examinations, but this is just for the sake of understanding. So without any scale, without any proper marking and all, so just this is for the sake of understanding only. So here this is the equation of given curve, or we can say this is the given curve y equal to f of x. This is the point where the tangent is drawn, and here this is the point that you have to find out. So you have to find a point on the curve. So right, so here this point A coordinates that you have to find out. This is the given curve, and according to them, the tangent which is drawn at point A is parallel to this line. So friend, this is the given line. So this is the given line which is parallel to the tangent. So this is somewhat a given system in the problem. So now we know from the coordinate geometry, if two lines are parallel, so if two lines are parallel, then their slopes are always equal. So if two lines are parallel, then their slopes are always equal. So what is the slope of this given line? So slope of this given line is 3. And what will be the slope of the tangent then? It will be also 3. So right, so please observe the slope of this given line is 3, and obviously the slope of tangent is also 3. The reason is tangent and the given line are parallel to each other. So understand this thing. So therefore I am considering here the given line and tangent are parallel to each other. So let me mark in this way, tangent is parallel to the given line. Therefore, slope of tangent is equal to slope of given line. Understand this concept? If the two straight lines are parallel to each other, then their slopes are always equal. So finally, the slope of tangent is equal to slope of given line is equal to 3. But you can substitute that slope of tangent here in this equation, which I marked this as 1. So from equation 1, slope of tangent was equal to 3x square minus 4x minus 1. Substitute the slope of tangent as 3. So 3 equal to 3x square minus 4x minus 1. Shifting this 3 on this side. So this is 3x square minus 4x minus 4 equal to 0, which is a quadratic equation. So let's factorize this. This is 4 3s are 12. You have to factorize this 12 such that the difference is minus 4. Means is it minus 6 plus 2? So minus 6 plus 2 are the factors. So 3x square minus 6x plus 2x minus 4 equal to 0. Taking this 3x common from this first two terms leads to x minus 2. Taking this 2 common from these two terms, so x minus 2. So overall the factors are x minus 2 and 3x plus 2 equal to 0. This first term x minus 2 equal to 0, and separating these factors 3x plus 2 equal to 0. This leads to two different values of x. The first one is x equal to 2, and the second one is x equal to minus, is it 2 by 3? So it's a minus 2 by 3. So here we got the point x. So right, so can you find out the value of y? Yes, it is very easy to find out. Since the interesting part about this point A is this point lies on the curve, this point lies on the tangent. So out of which, since there are two coordinates to the point x and y, we already got the value of x. So let's say we got x, then the question is how to find y. So this is very interesting discussion, friends. Since we got the value of x, how to find y? See, understand, this point A lies on the graph. So this point A lies on the graph means this point must satisfy the equation of curve or the equation of the graph. So right, so this is a rule from the locus. If a point lies on the locus, then it must satisfy the equation of locus. If a point lies on the circle, it will satisfy the equation of circle. If a point lies on the parabola, it will satisfy the equation of parabola. If a point lies on this curve, then it will satisfy the equation of that curve. Since we know the value of x, just find out the value of y by substituting over here. So here I am once again using this expression for y as x cube minus 2x square minus x, and it's my request to substitute the value of x equal to 2 and x equal to minus 2 by 3. So let's, for x equal to 2, I am substituting 2 first, so it's a 2 cube minus 2 into 2 square minus 2. Quickly find out and also substitute x is equal to minus 2 by 3 here in the same expression. So minus 2 by 3, its cube, minus 2 into minus 2 by 3, its square, and minus of 2 by 3. So I request every one of you, please simplify and find out these values of y. I hope every one of you are ready with the final answer. So what about this? So 2 cube is 8, minus twice of this is 4, which is plus 8 minus it cancels out. So the first value of y is minus 2. And if you simplify this one without wasting your time, I am mentioning this as minus 14 by 27. You have to cross check this value. Please cross check whether this value is correct or not. So I am not wasting your time on this one, but here we got the value of y. So whenever x is 2, then y is minus 2, and when x is minus 2 by 3, y is minus 14 by 7. So the point may be 2 comma minus 2, or the another point may be it's a minus 2 by 3 and minus 14 by 27. So there are two possibilities for this point A. Since we know it might be possible that this curve intersect this tangent is parallel to this line. So there might be a possibility that as far as circle is concerned, we can draw two different tangents which are parallel to each other. This might be the possibility. I am not saying it's an exact one, but if you check this circle, if you draw the two tangents, this might be the parallel to each other, or there are two different possibilities of the tangent. So that's why there might be two different points on the curve. So that might be the possibility. But let's see, our point at the end is covered. Here you have to find a point of the curve which is which lies on the curve and tangent is parallel to this line. So here we got this point which is lies on the curve and the tangent is parallel to the given line. See, understand, let me explain you the entire theme of this problem. See, they provided you the equation of curve. So see, don't waste your time in the calculation. Try to give importance to the theme of the problem, or always try to give importance to the understanding of the problem, because they might will change the digits in the examinations or in your any type of objective examination. Give importance to the theme of the problem. And friends, let me give you the theme of the problem. So here they provided you the equation of curve, that is nothing but y, and they expect a point A on the curve where the tangent is drawn. So their requirement is the point A coordinates where the tangent is drawn, and according to them, this tangent is parallel to the given line. So let me explain you the theme of this problem. So first of all, start with this given equation of curve, find out its derivative, and you know that derivative is nothing but the slope of tangent. We reached up to this point after the derivative, but we don't know the value of x because the point is the real requirement of this question. So we don't know the value of x and y, so keep this thing as it is. But they provided you the additional data. This tangent is parallel to the given line. So what is the equation of given line? If you observe, this is 3x minus y plus 1 equal to 0. Find out its slope of this line, which is the minus x coefficient divided by y coefficient leads to 3. But if two lines are parallel to each other, then their slopes are always equal. This is the concept from the lines. So if two lines are parallel to each other, then the lines are always, the slopes are always equal. So therefore the slope of the given line and the slope of the tangent are equal. So hence the slope of tangent is also 3. So once we got the slope of tangent equal to 3, substitute over here, simplify, factorize this equation, find out the value of x. And the interesting part is this last step, observe it carefully. Since this point, this is the concept from the locus. Let me tell you friend, this is the concept from the locus. If a point lies on the locus or on the curve, it must satisfy the equation of curve. Since this point A lies on this curve, and we got the x coordinate of that point, so you can substitute that x coordinate in the equation of curve. This is the rule from the locus. that we already studied in the locus. If a point lies on the locus, then it must satisfy the equation of locus. If a point lies on the any graph or any curve, then it must satisfy the equation of that graph or the curve. So this point must satisfy this equation of curve. So here I substituted these values of x here in this equation of curve, and at the end, after simplification, you got the corresponding values of y, and that will give you the point or the coordinates of the point A. So there are two possibilities. So that might be because of the curve, and there might be because of two parallel tangents we can draw simultaneously to curve. Don't go in details of that because there is no need to draw the exact curve over here, but at the end what is important is we got the point where the tangent is drawn. Okay, so we've covered this first somewhat tricky and somewhat very different type of problem from the previous lecture. Okay, let's start with the second one. It's almost a similar one. Find a point on the curve. Same, you have to find a point on the curve is you have to find the coordinates of the point A. This is the given equation of curve where tangent is perpendicular to this line. In previous problem, the tangent was parallel, and in this problem, tangent is perpendicular. That's all. This is the simple difference. In previous case, it was parallel, and in this case, it is perpendicular. There is only difference between these two problems. In previous case, tangent was parallel, and in this case, tangent is perpendicular. Okay, then it's an exactly similar problem. Let me start with the given equation of curve, which is y is equal to under root x minus 3. Let's differentiate this y with respect to x. So here I am differentiating this under root x minus 3 with respect to x. So this dy by dx, derivative of root x is 1 upon 2 root x, even though it's a composite, into derivative of composite part is x minus 3. If you observe, root is the first, x minus 3 is the second. So let's mark this root as the first, x minus 3 as the second. So friends, please apply a rule of composite, that is nothing but a chain rule. In chain rule, it's a derivative of first into derivative of second. So at the end, final answer for dy by dx is 1 upon 2 into under root x minus 3, because derivative of x is 1, derivative of 3 is 0. So 1 into something is 1, so I am keeping this thing as it is. The important thing is derivative is nothing but the slope of tangent. This is the concept that we discussed in my previous video. I hope every one of you watched already. So this is very important concept. Finding a derivative of curve is nothing but the slope of tangent. But we don't have a value of this x. The reason is we want to find the coordinates of the point A. Okay, then write down the given equation of line. The next thing is given equation of line. The given equation of line is 6x plus 3y minus 5 equal to 0. Let's find its slope. So its slope is minus x coefficient divided by y coefficient. So slope of this line is minus 2. Okay, then my question is, if these two straight lines are perpendicular to each other, then what is the correlation between these two lines? So this is the concept from coordinate geometry, lines. If the two lines are perpendicular to each other with the slopes m1 and m2, then m1 into m2 is minus 1, or the slope of the second line is negative reciprocal of another. Understand, this is the concept from coordinate geometry. If the two straight lines are perpendicular to each other, then the product of their slopes is always minus 1, or if you shift this m1 on this side, m2 is minus 1 upon m1, or in another word we can say it's like a negative reciprocal. It's like a negative reciprocal. Okay, so if this is the slope of line, but it is given tangent is perpendicular to this line. Tangent is perpendicular to given line. So please understand this. Tangent is given perpendicular to the line. So please observe here, the tangent is perpendicular to this given line. So then, what is the slope of tangent? So if two lines are perpendicular, then the slope of the one of the line is negative reciprocal of another. Okay, then put a minus sign to this, that will leads to plus, and just take a reciprocal, it is equal to 1 by 2, and here we got slope of tangent. So obtaining the slope of tangent is very simple. Slope of tangent is a negative reciprocal, because the concept is of two perpendicular lines. So here two lines are perpendicular, therefore the slope of tangent is a negative reciprocal. If you put a negative, it becomes plus, and the reciprocal of 2 is 1 by 2. And friends, at the end we got the slope of tangent. Okay, since we got the slope of tangent, now we can substitute this value of slope of tangent over here in this equation 1. So I am mentioning here from 1, which is slope of tangent is equal to 1 upon 2 into under root x minus 3. Please substitute slope of tangent as 1 by 2 is equal to 1 upon 2 into under root x minus 3. This 2 and 2 cancels. Shifting the square root on this side, so it's under root x minus 3 equal to 1. And squaring on both the side. If we take square on both the sides, so x minus 3 equal to 1 square. This leads to x equal to 4. And here we got the value of x is equal to 4. So right. So how to obtain the value of y? Since this point lies on the graph. So let me explain you with simple graph. So this is the given equation of curve. Let's say I'm discussing it tentatively, not with the scale, not according to the exact dimensions and the points and all. This is just for the sake of understanding. Let's say this is the given equation of curve, and we are drawing one tangent to this curve at this point. This is the requirement of the point. So they want the coordinates of this point x comma y. This is the point where the tangent is drawn. According to them, this tangent is perpendicular to this given line. This might be the given line. Understand this. This might be the given line. So I am talking about the given line 6x plus 3y minus 5 equal to 0. This is the given line to which this tangent is perpendicular. Right? Okay, then we reached a point where we got the x coordinate of the point. The real question is how will you obtain the y? So right, so understand this is very tricky part of this question. How will you obtain the y? Since this point A lies on the curve or lies on the graph, so here comes a concept from the locus. If a point lies on the circle, it will satisfy that equation of circle. If a point lies on the parabola, it will satisfy the equation of parabola. If a point lies on the curve, it will satisfy the equation of curve. If a point lies on the line, it will satisfy the equation of line. Since this point lies on the graph or the curve, it will satisfy the equation of that graph or the curve. So therefore, I am substituting this value of x directly into the equation of curve. So what is the equation of curve? Y is equal to under root x minus 3. So it's under root x minus, x value is 4 minus 3, which is under root 1. Under root 1 leads to the 1. So here we got the coordinates of the point A, 4 comma 1. This is the point which was the requirement of the problem, and here we got the corresponding point A. Try to understand a simple theme of this question within 2 minutes. They provided you the equation of curve. This is the equation of curve, and according to them, the tangent is perpendicular to this line. This might be the situation. The tangent which is drawn at point A is perpendicular to the given line. So do one thing, differentiate the given curve, find out its derivative, and you know the concept. Derivative is nothing but the slope of tangent. Only thing is we don't know the value of x, so keep this thing as it is, mark this as 1. This is the equation of given line which is perpendicular to the tangent. Find out its slope using minus x coefficient divided by y coefficient, and perpendicular this line, see the slope of this line is minus 2, but this line is perpendicular to the tangent, and we know from the coordinate geometry from the chapter lines, if two lines are perpendicular, then their slopes are negative reciprocal. See, this is the simple trick, negative reciprocal. So how to obtain the slope of tangent? Put a negative sign to this, it becomes plus 2, and take a reciprocal, it becomes 1 by 2. So here we got the slope of tangent. Now, once we know the slope of tangent, substitute back over here in this equation 1, and if you simplify it, you will get a value of x. Once we know the value of x, which is the coordinate of the point A, but understand this thing, this point A lies on this graph. Point A lies on this curve. Therefore, this point must satisfy the equation of curve. So substitute this value of x is equal to 4 in this given equation of curve, and that will lead to the value of y. And at the end, here we got the coordinates of the point A, 4 comma 1, where exactly the tangent is drawn. I hope you got this concept from this question number 2. Okay, then try to understand the question number 3. Now this is something different and very interesting one. This is the question, very interesting one and also important for various objective examinations. So please mark this as important one. Find the equation of tangent to this curve. So first of all, read this entire problem, friends. Find the equation of tangent to this curve, but according to them, the tangent is parallel to the x-axis. This is something different. So please try to understand. The tangent is parallel to x-axis. This is conceptual. This is interesting one, and this is the tricky part of this question. Okay, we will see the tricky part later on. Let me start with the given equation. Of course, I am talking about question number 3, and start with the given equation of curve, which is x square plus y square minus 2x minus 4y plus 1 equal to 0. Okay, so since we are using applications of derivative to the tangents and normal, and you know that derivative is nothing but slope of tangent. For that, let's differentiate this entire curve with respect to it. So derivative of x square, derivative of y square, taking this minus 2 outside, so derivative of x minus 4 outside, derivative of y, and the last one is derivative of 1 is equal to 0. And if you observe, this is the pure derivative. This one is pure derivative. So what is the derivative of x raised to n? So it is n into x raised to n minus 1. That is 2 into x raised to 2 minus 1. What about this? If you observe, this is not a pure case. Treat this as a composite. Let's mark this as 1, this as 2. We already discussed this case. This is the pure derivative, but this is not. So let's apply composite case. First of all, x raised to n. So it's a 2 into y raised to 2 minus 1. We finish with the derivative of 1 into derivative of 2, that is nothing but y. Minus twice of derivative of x with respect to x is 1. Rest of the thing I am keeping as it is. This is minus 4 times dy by dx as it is. Derivative of 1 with respect to x is 0, keeping the right hand side 0 as it is. If you observe, you can divide throughout by 2, so it's a x plus y times dy by dx minus 1 minus 2 times dy by dx equal to 0. So here I divided throughout by 2. So if you observe these two terms, dy by dx is common, so let's take that dy by dx outside. It's a y minus 2 dy by dx, and these two are the terms without dy by dx. Let's shift them on RHS. So this minus 1 on RHS becomes plus 1, and I am shifting this plus x on RHS becomes minus x. So it's a 1 minus x. Please shift this bracket on RHS, and finally the dy by dx is 1 minus x upon y minus 2, which is nothing but the slope of tangent, and please mark this as 1. Very, very important point of this problem now. So let me discuss very important and very interesting and very tricky part of this problem. That is nothing but this sentence. According to them, the tangent is parallel to x-axis. See, this is very interesting. I found this part to be a very interesting and very tricky part of this question. So somewhere you have to apply your mind to understand this wording. According to them, the tangent is parallel to x-axis. What will happen if a tangent is parallel to x-axis? So let me draw the situation, tentative situation. Let's say this is the graph, or this is the given curve. And if you draw a tangent to this curve at this point, this is x-axis, y-axis, origin. So let me tell you, friends, all of my graphs or these curves or drawings are not according to scale, or not according to point, or not according to the given problem also. This is only for the sake of understanding the situation given in the problem. So right, so don't elaborate this one, or don't correlate this one with the exact one-on-one with the given problem. This is just for the sake of understanding what exactly the situation is hidden inside this problem. So this is the way that you have to understand this graph. Okay, so let's say this is the given curve and this is the tangent. According to them, this tangent is parallel to x-axis. This is the interesting part. The tangent is parallel to x-axis. What will happen if a line is parallel to x-axis? What about its slope? What is the meaning of slope? Slope means either this situation or this one. If you drive a vehicle, right? So on this way, so on an increasing type, so or an increasing function, if it is an increasing function or if it is an increasing graph or if it is an increasing elevation, in that case if you drive a vehicle, we say it's a positive slope. So right, so this is nothing but a positive slope. But what about on a declines? This is, you are taking the elevation, you are taking a height to the, you are giving a height to that particular vehicle, so obviously this is the positive slope. But what about this slope? So since this is a declining case, we say it's a negative slope. So this is a positive slope, this is negative slope. But what about if you are drawing a vehicle on a plain ground? So if you are drawing a vehicle on the plain ground or on the plain surface, obviously there will not be any elevation, right? Like this one or like a decline. So means if a line, if a surface is a flat and we are drawing a vehicle, obviously we say there is no slope. No slope means it's a zero slope. So over here we can say if it is a flat surface and you are drawing a vehicle on the flat road or the flat surface, obviously there will not be any incline or the decline cases, right? There is no inclination or the declination. So right, so in that case the slope is obviously zero. If you observe this tangent is parallel to x-axis. If it is a parallel to the ground or if it is a parallel to the x-axis, then in that case we say the slope of that line is equal to 0. So the slope of the tangent is 0 since the tangent is parallel to x-axis. This is, understand this thing, very interesting and very important one. So here we can say it's a positive slope like a +2 or +3. Here we can say it's a negative slope like a -2. But what about this case? On the flat surface or on the flat ground, we can say the slope is 0. Slope is 0. For this tangent which is parallel to x-axis, the slope is 0. So slope is 0 because of the tangent is parallel to x-axis. So please write down, given tangent is parallel to x-axis. Tangent is parallel to x-axis. Therefore, the slope of tangent becomes 0. So please substitute over here. The slope of tangent in this case is 0. Substitute and simplify. Substitute and simplify. I hope you got this concept. So let's substitute the slope of tangent equal to 0. So from this equation 1, I am substituting the slope of tangent is equal to 0. So 1 minus x, or ultimately its derivative is 0. 1 minus x upon y minus 2 equal to 0. If you substitute this y minus 2 on this side, so 1 minus x becomes 0. And if you shift this x on this side, so finally we got x equal to 1. So for this curve, we got x equal to 1. Okay, the next thing is, since we got x equal to 1, they want the equation of tangent. For that, let's try to find the value of y. Since this point lies on the graph, you can substitute the value of x equal to 1 over here in this equation. So I am substituting this x equal to 1 over in this equation. As we already discussed, if a point lies on the graph, it must satisfy the equation of graph. That's why I am substituting x equal to 1 over here. This is a 1 square plus y square minus 2 into 1 minus 4 into y plus 1 equal to 0. Okay, let's simplify this. It's a y square. This is plus 1 which is 2, 2 minus 2 is 0. So simply it's a y square minus 4y equal to 0. Taking this y outside, y minus 4 equal to 0. The first equation leads to y equal to 0 and the second part leads to y equal to 4. So here we got the two different values of y equal to 0 and y equal to 4. So the first combination is x which is 1 comma 0. The first point is 1 comma 0 and the second possibility is 1 comma 4. Okay, now we got the point on the graph. We got the point on the graph. Now we want the equation of tangent. So we got a point where the tangent is drawn. So we know the coordinates of the point A. Even we know the slope of the tangent. So right. So now we know the slope of tangent. In this case it is 0 and we know this point A, which is somewhere 1 comma 0 or 1 1. Let's consider one of them. Let's say it's a 1 by 1 comma 4. So now we want the equation of that tangent. So as far as this tangent is concerned, two data points are known to you. For the equation of tangent, we know that its slope is 0 and I am considering this one point, let's say 1 comma 4. Now tangent is nothing but a line, and how to find the equation of line? So when we know the slope, we know the point, let's use slope point form. So I am using here slope point form. What is the slope point form of a line? Y minus y1 equal to m into x minus x1. So please substitute. Y minus y1 is 4, slope of tangent is 0, x minus x1 is 1. If you 0 into something is 0, so y minus 4 is equal to 0. This leads to y equal to 4, and friends, this is nothing but the equation of tangent which is required, and you can understand the line which is parallel to x-axis is always y equal to constant. So this is from the coordinate geometry, and this is the required equation of tangent y equal to 4. So this one was also a tricky problem. That's why this is the heading, special problems on tangents and normal. These are not the ordinary questions of about finding a tangents or normal. You will observe some tricky parts in this type of problem where you have to understand the meaning of these things from the coordinate geometry or from the lines or from the locus. Understanding the concept is very important for this kind of problem. So I hope you got this question number 3. And friends, to solve this kind of problem, few data points or few equations or few concepts from the lines or the locus are also required. Make sure you have a data with you from this coordinate geometry also. Okay, then the next is question number 4. According to them, here instead of tangent you have to find the equation of normal. They want the equation of normal. So find the equation of normal to this given curve and parallel to this line. This is somewhat like a question number 1 where the tangent was parallel to this line, and here according to them normal is parallel to this line. So let's try to tackle this question. So here I am starting with given curve, equation of curve is, or equation of graph or equation of given curve is 3x square minus y square equal to 8. Without wasting the time, just start differentiating this one with respect to x. So this is, I am taking this 3 outside, derivative of x square, then derivative of y square, and then I am differentiating RHS. Taking this 3 outside, derivative of x square is 2 into x raised to 2 minus 1. Derivative of y square using composite, derivative of y raised to 2 is 2 into y raised to 2 minus 1, and then the derivative of y, which is dy by dx. So here I am applying the chain rule, and on the right hand side derivative of constant is 0. So if you want, you can divide throughout by 2 plus shift this is 6x, or you can cancel out this 2 throughout. Let's say I am dividing it by 2 throughout, then shift this 3x on RHS, so it's a minus y dy by dx. Please shift this 3x on RHS, it becomes minus 3x. So final answer for dy by dx is 3x divided by y, which is nothing but the slope of tangent. Okay, so it's my request to everyone, please differentiate the given curve first with respect to x and obtain the dy by dx. Why? The reason is quite simple, because we are only working on this simple concept. Derivative is nothing but the slope of tangent, so which we already discussed in my previous video. Finding a derivative is nothing but the slope of tangent. So that's why every time whatever is the given curve, differentiate that with respect to x and obtain dy by dx, and obtaining a derivative is nothing but the slope of tangent. I am marking this given equation of curve as 1, slope of tangent as 2. According to them, this you have to find the equation of normal actually instead of tangent, and according to them the normal is parallel to this line. So let me write down the given line. Given line is x plus 3y. Friends, I am shifting this 4 on LHS, so it's x plus 3y minus 4 equal to 0. Then the slope of this line, slope of given line is minus, I am using a formula to find the slope. How to find the slope of a general line? Minus x coefficient divided by y coefficient. So here we got the slope of this line. So according to them, this line is parallel to the normal. So right, according to them, this line is parallel to the normal. So then what is the slope of normal? The slope of normal, that is I am indicating it by m of n, is also same. The reason is, if two lines are parallel, then their slopes are always equal. We know this concept. If the two lines are parallel, then their slopes are always equal. Since according to them this given line and normal are parallel to each other, therefore I am considering the slope of normal equal to minus 1 by 3, which is exactly same. Then what is the correlation between the slope of tangent and slope of normal? We know that tangent and normal are actually perpendicular to each other, and slope of tangent and slope of normal are negative reciprocals of each other. We already discussed this concept in my previous video on the basics of tangents and normal. Try to recall it. Tangent and normal are perpendicular to each other, then their slopes are negative reciprocals of each other. Then the slope of tangent, that is m of t, is a negative reciprocal of slope of normal. If you want to find the slope of tangent, I am giving you a simple trick. Apply a minus sign and the reciprocal. If you apply a minus sign to this, it becomes plus, and just take a reciprocal of 1 by 3. Reciprocal of 1 by 3 is plus 3. So this is the slope of normal. And if this is the slope of normal, just take a negative reciprocal. This is the trick. So negative reciprocal. If you apply the negative, it becomes plus, and the reciprocal 1 by 3. The reason is, use this negative reciprocal concept in perpendicular cases. If the two straight lines, understand these two things, if the two straight lines are parallel, then their slopes are equal. But if two straight lines are perpendicular, then their slopes are negative reciprocal. So here you have to use these two different concepts: parallel, equal slopes; perpendicular, negative reciprocal. This is the hint. Okay, so finally we got the slope of tangent using the slope of normal, using the slope of given line. Understand this. This one was the given line, this one was the slope of line which was parallel to the normal, and normal was perpendicular to the tangent. So this is the way we obtain the slope of tangent. Now substitute the slope of tangent in equation number 2. So from 2, this derivative of the slope of tangent, which is 3x divided by y, please substitute the slope of tangent is equal to 3 here. So this 3x is equal to 3. So here I am substituting this is equal to 3. So instead of slope of tangent, let's say this is equal to slope of tangent, and we know that slope of tangent is 3. So instead of this, let's say you are substituting this as 3. So this 3 and 3 cancels. If you substitute this y on RHS, that leads to x equal to y case. So here we got finally the correlation. We didn't got exact value of x and y, but we got the correlation, and that will serve our purpose of finding the individual coordinates. So do one thing, substitute x equal to y over here in the equation 1. From equation 1, I am substituting x equal to y value, or even you can substitute y as x. So this is 3x square minus, I am replacing y as x. This is x square is equal to 1. 3x square minus x square is a 2x square is equal to 1, leads to x square is equal to 4, leads to x equal to plus minus 2. So here we got the two individual values of x plus minus 2. Since x is equal to y, therefore even we can say y is also plus minus 2. Finally we got both the values of x as well as y. If you split this into two parts, the point may be 1, 2, 2, plus 2, or if you say it's a minus 2 combination. So if both the values are plus 2 or both the values are minus 2, this might be the combination of the given point. Okay, so finally we got a point on the graph or point on the curve. But the requirement of the problem is not the point. The requirement of the problem is about finding equation of normal. They want the equation of normal. But friends, we already know the point, we know the slope, we can use a slope point form to find the equation of normal. So out of these two, I am considering, let's say, the point A. So to obtain the equation of normal, we have two data points. First, the slope of normal is minus 1 by 3, and this is the point 2, 2. Let's mark this as x1, y1. So slope is known, point is known. How to find the equation of normal? So let's use slope point form. So I am using the slope point form of line, which is y minus y1 equal to m into x minus x1. So y minus y1 is 2, slope of normal is minus 1 by 3, x minus x1 is 2. Please simplify, shifting 3 on LHS, so 3y minus 6 is equal to multiply minus inside, minus x plus 2, shift entire data on LHS. So it's x plus 3y minus 8 equal to 0, which is the required equation of normal, which was asked in the problem considering this point A 2, 2. Finally we got the equation of normal. So this one was also somewhat tricky question. So just understand, somewhere you have to join the concepts from the lines with this article about tangent and normal. So what about the theme of the question? So they want the equation of normal. So be careful here. So in previous questions we obtain the equation of tangent or the point, but here particularly they want the equation of normal. So which is parallel to this line. Okay, do one thing, differentiate. Let me summarize this entire problem in 1 minute. This is the equation of curve. Start differentiating this, obtain the dy by dx. And understand this, obtaining a dy by dx is nothing but the slope of tangent. So this is the concept that we know. Now this is the given line which is parallel to the normal. So let's utilize this line. So this is the equation of given line. Its slope is minus x coefficient divided by y coefficient. And since, understand this thing, this line is parallel to the normal. This line is parallel to the normal. If two lines are parallel, then their slopes are also equal. The slope of the given line is equal to the slope of normal. So here we can say the slope of line and slope of normals are equal since they are parallel. But what about tangent? Tangent is a line perpendicular to the normal. So how to obtain the slope of tangent? Concept is negative reciprocal. If you apply the negative sign and if you take the reciprocal, it becomes minus becomes plus and the reciprocal leads to 3. So apply the negative reciprocal concept if it is a perpendicular thing, and since tangent and normal are perpendicular, so obtain the slope of tangent by taking negative reciprocal of this value, and at the end we got the slope of tangent. Substitute this value over here in the equation 2, that leads to x equal to y condition. But we can easily find the individual values by substituting this y is equal to x over here in this given equation of curve, because the point lies on the curve. So we can substitute this value of y over here, simplify, we got the value of x, but I considered one of them to obtain the equation of normal. If you want, you can solve for the second one also. But as now we got x as well as y by substituting here in this equation 1. At the end, we know the two data points about the normal. See, normal is a line. And finding the equation of normal is all about finding the equation of line. This is the slope of normal, this is the given point, and how to obtain the equation of normal or the equation of line using slope point form. So why the slope is known, point is known, so please use slope point form. Y minus y1 equal to m into x minus x1. Substitute and find out your answer. The interesting part about these things is, this entire common process is irrespective of the type of the curve or irrespective of the type of the given equation of curve, this process is common to all. Means you can apply this process of finding equation of tangent or equation of normal to the any curve that is known or unknown to you. You can apply this concept to line, circle, parabola, ellipse, hyperbola, or any other curve that is known or unknown to you. That is the beauty of this article, which gives you the equation of tangent and normal to any type of curve. Any type of curve. So okay. Then the last problem from this section. This line touches to this curve at point 2, 3. Find the values of A and B. So according to them, this is the equation of curve. This is the, let's say, equation of curve. I am drawing it tentatively. This is the equation of curve, and this line touches to the curve. Touches to the curve means the line is tangent. So so the equation of tangent is actually given. So y is equal to 4x minus 5 is the equation of tangent given. So understand, friends, this line touches means this line is tangent. So this line touches to this curve. So the equation of curve is y square equal to ax cube plus b. So right, am I right? So this is the equation of curve, this is the equation of tangent, and this is the point where the tangent is drawn. So understand, this is the point where the tangent is drawn. So 2, 3 is a point where the tangent is drawn. And at the end, with these data points, we have to find the value of A and B. Very interesting one. So let me start with equation of curve. So equation of curve is y square equal to ax cube plus b. So let's differentiate this one with respect to x. Taking this a outside, I am differentiating this x cube, and let's differentiate this b. So derivative of y square with respect to this is not a pure, apply chain rule, power first, y second, derivative first. Derivative of y square is 2 into y raised to 2 minus 1. So I am treating this as a composite. Derivative of 2, that is derivative of y is dy by dx. This is the pure derivative. This is 3 into x raised to 3 minus 1, and b is the individual constant whose derivative is 0. Understand this? B is a constant, and derivative of constant is always 0. Okay, shifting this to y on RHS. So final answer for dy by dx is 3ax square divided by 2y, and you know that derivative is nothing but the slope of tangent. This is important. So derivative is nothing but the slope of tangent. Okay. Finally we got the expression for the slope of tangent. But they already provided the equation of tangent. So what is a given equation of tangent? So friends, given equation of tangent is y equal to 4x minus 5. So if you shift this y on this side, so 4x minus y minus 5 equal to 0, which is the general equation of line, then what is the slope of tangent then? How to find the slope of a general line? Very simple. Assuming this as ax plus by plus c equal to 0, this looks like a general equation of line, and the slope of the general equation of line is minus x coefficient divided by y coefficient. In this case it is minus 1. So finally we got the slope of tangent, which is equal to plus 4. So see, they already provided the equation of tangent. Find out the slope of tangent. So in this case it is 4, and substitute that slope of tangent over here in equation number 1. So I am substituting this in equation number 1, so which is 3ax square divided by 2y is equal to slope of tangent is 4. So shifting this 2y on this side, so 3ax square is equal to 8y. So let's mark this as, we mark this as 1, or let's mark this curve as a 1, this expression as a 2, and let's mark this as 3. But still, we got this equation 3, but we don't have a value of a up till this particular point. But let me explain you the very interesting concept. They also provided you this point 2, 3. So let me explain you on the graph. If this is the equation of curve, let me explain it here. So instead of drawing a new graph, let me explain you over here itself. Since this point A, understand this, this is very interesting. The beautiful part about this point A is, this point A lies on the graph, this same point A lies on the tangent, and let me tell you one extra point, this point also lies on the normal. So the beautiful part about this point A is, it lies on the graph, it lies on the given equation of curve, it lies on the tangent, it lies on the normal. And we know a concept from the locus, if a point lies on the locus, then it satisfies the equation of locus. Since this point A lies on the graph, it will satisfy the equation of graph or equation of curve. This point lies on the tangent, it will also satisfy the equation of tangent. This point lies on the normal, it will also satisfy the equation of normal. Means this one single point will satisfy the equation of curve, equation of tangent, equation of normal. This is the concept from the locus that I am taking. So here you can freely substitute this point here in this condition. So this point A is 2, 3, and this as an x, this as a y. You can substitute it over here. This is 3a times x is 2, its square, and 8 times y value is 3. So let's simplify. This is 4 3s are 12, so it's a 12a is equal to 24. Shifting 12 on this side, so a is equal to 2. So finally we got one of the unknown a is equal to 2. So meaning this got this value of a. What is the requirement of the problem? We have to find the values of this a and b. So we got a. How to obtain b? See, from 1, the equation of curl is y square is equal to, I am substituting the value of a now. This is twice of x cube plus b. So anyone who can guess how to find the value of b? See, I already discussed the importance of this point. This point lies on the tangent. I took a benefit of it over here. But the same point also lies on this graph, means on this curve. So you can substitute this point inside this curve. So the point A is 2, 3. You can substitute this point inside this curve. So please substitute the value of x and y over here. So y is 3, its square. 2 into x is 2, its square. Plus b. So 3 square is 9. 2 square is 4 into 2 is 8 plus b, shifting 8 on this side, and here we got the final value of b, which is equal to 1. Okay, so please observe here, I am taking a very huge benefit of this point a. So here I substituted this point a which lies on the tangent. So here I substituted the value of x and y, or in this step number 3 I substituted the value of x and y because that point a lies on the tangent and this is nothing but the expression for the slope of tangent. So I substituted that point on this tangent, right? Okay, then I substituted the same point inside this curve because this point also lies on the curve. So if you substitute that point inside the derivative, that will leads to the one of the value of a is equal to 2, and if you substitute the same point in the equation of curve and after simplification you will get the value of b. And here we covered this fifth question, which was a very simple and very interesting one to obtain this value of a and b. So friends, today's session was not an ordinary session about finding the tangent and normal that we discussed in my previous video. So if you know my previous video, if you remember, we discussed how to find various equations of tangents and normal at given point, which was absolutely a normal ordinary type of problems. So we mean straightforward problems was there. But the today's session was something different, where we obtain the equation of tangent or even equation of normal or unknowns or something else, but with some hints and tricks from the lines chapter or from the concept of the locus. So please revise this kind of questions. This is the real question that you might will face in your objective examinations. I hope at least this video will give you a certain idea about this kind of problem and will help you at least a little bit in your objective preparation. Hope in next lecture we will start with new article on applications of derivative. So in next video we will see fresh and totally new application of derivative. Till then, goodbye and take care.